Welcome back, ladies and gents. In this teaching video, I'll be looking at 4.2 quartic graphs. 4.2 represents Chapter 4, Section 2 of the Pearson A-Level Maths Pure Maths Year 1 textbook. So I'm going to start this teaching video by going through the key facts of this particular section. Firstly, what is a quartic function? A quartic function is a function of the form f of x equal ax to the power 4 plus bx cubed plus cx squared plus dx plus e, where a, b, c, d and e are constants. And, I repeat, and a is not equal to 0. Right, I'm going to take a step back and start reflecting on what I've written. Suppose a is equal to 0. If a is equal to 0, this function reduces to bx cubed plus cx squared plus dx plus e, which is a cubic function. To ensure that this function remains as a quartic function, we must have the condition that a is not equal to 0. So there are two different types of quartics. You've got a positive quartic and you've got a negative quartic. Let's have a look at these two scenarios. So the first scenario, a is positive. So if a is positive, the coefficient of x to the power 4 is positive, we have a positive quartic. Now the shape that a positive quartic takes is a W shape. Right, scenario number 2, a is less than 0, a is negative. The coefficient of x to the power 4 is a negative. In this case, we have a negative quartic. Now, a negative quartic takes an M shape. Okay, an M shape, or you could say upside down W. Right, now we're going to move on to two special types of quartics. So, special cases. The first one is f of x equal x to the power 4. Now, over here, a is equal to 1. The coefficient of x to the power 4 is 1. This is a positive constant. What shape does this particular graph take? Well, this graph over here will take a U shape. But notice that at the vertex we have a flat bottom. When we're looking at quadratic graphs, there isn't a flat bottom at the vertex. A flat bottom like this. So this flat bottom makes it unique in comparison to the quadratic graph. Now, the next special type of quartic, f of x equal minus x to the power 4. Over here, a is equal to negative 1, okay, which is less than 0. We have a negative constant. In this case, the shape of the graph will be an upside down U shape with a flat bottom at the vertex. Okay, so that there is the key facts of this particular section. We're going to use this key knowledge in order to sketch quartic graphs. Let's have a look at some examples. Sketch the following quartic graph and indicate clearly the points of intersection with the axes. So part A, we're going to be sketching this particular graph. We're going to start off by identifying the coefficient of x to the power 4. In other words, the value of a. So I've got x multiplied by x, multiplied by another x, multiplied by this final x. Remember, ladies and gents, we are multiplying out 4 brackets. Anyways, this reduces to x to the power 4. So the coefficient of x to the power 4 is 1. In other words, a is equal to 1, which is positive. So we have a positive quartic, and therefore we can conclude that the shape of the graph is a W shape. Now I'm going to go ahead and work out the y-intercept. For the y-intercept, I need to substitute x equal to 0. So if I go back to my original equation, I'm replacing the x's with 0. This gives me y equal 1 multiplied by 2 multiplied by 3 and multiplied by 4. This reduces to y equal to 24. Hence, the y-intercept is 0, 24. Okay, so now I'm going to be working out the x-intercepts. So x-intercepts. In this case, I need to substitute y equal to 0. So if I go back to my original equation, I'm going to now replace the y with 0. So my equation reduces to x plus 1 in brackets, x plus 2 in brackets, x plus 3 in brackets, and x plus 4 in brackets equal to 0. The roots, or you could say solutions to this particular equation, are x equal minus 1, minus 2, minus 3, and minus 4. So my x-intercepts are minus 1, 0, minus 2, 0, minus 3, 0, and minus 4, 0. Now I'm going to sketch my graph. So here's my coordinate axes. X-axis, y-axis. Okay, so I'll label my x-intercepts, which are minus 1, minus 2, minus 3, minus 4. And my y-intercept is 24. This is a sketch, it's not accurate. The key things that you get marks for is the shape of the quartic, the y-intercept, and the x-intercepts. Okay, notice that in the equation there are no repeated factors. So the curve will not bounce at any of the x-intercepts. What it will do is cut the x-intercepts. So let's sketch the graph now. Cut at x equal minus 4, cut at x equal minus 3, cut at x equal minus 2, cut at x equal minus 1, and then cut at y equal 24. So that there is my quartic graph. I've got the graph y equal x plus 1, x plus 2, x plus 3, and x plus 4, each of these individual components in brackets. Moving on to part B. Now we're going to sketch this graph. Let's start off by working out the coefficient of x to the power of 4. So I've got minus x multiplied by x, multiplied by x, multiplied by another x. This here reduces to minus x to the power of 4. So the coefficient of x to the power of 4, in other words, the value of a is a negative 1, which is less than 0. So now we have a negative quartic. A negative quartic takes on an M shape. So we've got the shape of the graph. Let's go ahead and work out the y-intercept. So for the y-intercept, I need to substitute x equal 0. I'm replacing the x's in this equation with 0. This gives me y equal 1 multiplied by 1 multiplied by minus 3 multiplied by minus 2. This reduces to 6. So my y-intercept is 0, 6. Okay, now I'm going to go ahead and work out the x-intercepts. I need to substitute y equal to 0. So if I go back to this equation, I'm now replacing the y with 0. So the equation reduces to 1 minus x, x plus 1, x minus 3, x minus 2, each of these individual components in brackets equal to 0. The roots, or you could say solutions, of this particular equation are x equal 1, x equal minus 1, x equal 3, and x equal 2. So my x-intercepts are 1, 0, minus 1, 0, 3, 0, and 2, 0. Now I'm going to sketch my coordinate axes. Y-axis, x-axis. Let's label the x-intercepts. So we've got minus 1, 1, 2, and 3. The y-intercept is 6. Again, it's a sketch, it's not accurate. The key things that you get marks for is the shape of the graph, the y-intercept, and the x-intercepts. Okay, notice that if you go back to the original equation, there are no repeated factors. Hence, the graph will not bounce at any of the x-intercepts. It will cut the x-intercepts. Right, so what does the sketch look like? Well, it will look something like this. Cut at x equal minus 1. Cut at y equals 6. Cut at x equal 1. Cut at x equal 2. And then cut at x equal 3. So that there is a sketch of my graph. I can label this graph. It is y equal 1 minus x, x plus 1, x minus 3, and x minus 2. That there, ladies and gents, is the icing on the cake. Let's have a look at part C. Okay, so this is the graph that we're going to sketch. We're going to work out the coefficient of x to the power 4. Firstly, we've got x multiplied by x squared multiplied by x. This reduces to x to the power 4. So the coefficient of x to the power 4 in this case, or you could say the value of a is 1. This is positive. So we have a positive quartic W shape. Now let's work out the y-intercept. Substitute x equals 0. So replace the x's with 0. You get y equal 0 multiplied by 1 squared multiplied by 2. This gives you y equals 0. So the y-intercept is 0, 0. Let's find the x-intercepts. So now we need to substitute y equals 0. So in our original equation, we're going to replace the y with 0. So the equation reduces to x in bracket x plus 1 squared in bracket x plus 2. This is equal to 0. So the roots, or you could say solutions of this particular equation are x equals 0, x equal minus 1, and x equal minus 2. So my x-intercepts are 0, 0, minus 1, 0, and minus 2, 0. Okay, so now I'm going to sketch the graph. So here's my coordinate axes. Y-axis, x-axis. So my x-intercepts are 0, minus 1, and minus 2. And my y-intercept is 0 as well. Now if you go back to the original equation, we notice that x plus 1 is a repeated factor. This means that the graph will bounce at the x-intercept minus 1. But at the x-intercepts 0 and minus 2, it will cut the axes. So I'm going to bear that in mind when I sketch the graph. So we have a W shape. So this is what my sketch will look like. Cut at x equal minus 2. Bounce at x equal minus 1, so bounce off. Okay. And then cut at x equals 0. Okay, that there's my complete sketch of y equal x in bracket x plus 1 squared in bracket x plus 2. Okay, so now we have part D to complete. We're going to sketch this graph. Let's work out the coefficient of x to the power 4. So what we have over here is minus x squared multiplied by x squared. This reduces to minus x to the power 4. So the coefficient of x to the power 4, in other words, the value of a is negative 1, which is less than 0. So we have a negative quartic, and the shape will be M shape. Let's work out the y-intercept. substitute x equal to 0, replace the x's with 0 in the equation. So we have y equal minus 4 squared multiplied by minus 2 squared. Okay, so if we reduce this, we get y equal minus 64. So the y-intercept, ladies and gents, is 0 minus 64. Let's have a look at the x-intercepts. We substitute y equal to 0. So if I go back to my original equation, I'll replace the y with 0. So the original equation reduces to minus, in bracket, x minus 4 whole squared, in bracket, x minus 2 whole squared, equal to 0. So over here, we notice that the roots or the solutions of this particular equation are x equal 2 and 4. So my x-intercepts are 2, 0 and 4, 0. Right, so I'm going to sketch the graph now. Here's my axes. So I've got the y-axis and I've got the x-axis. My x-intercept are 2 and 4, and my y-intercept is minus 64. Again, it's not accurate. The key things that you get marks for is the shape of the graph, the y-intercept, and the x-intercepts. So we need to sketch an M shape. If we go back to the original equation, we have two repeated factors, x minus 4 and x minus 2. So at both of these x-intercepts, the curve will bounce. It will not cut, it will bounce. So I need to bear that in mind when I sketch the graph. So cut at minus 64, which is the y-intercept, bounce at 2, bounce at 4 as well, and then come back down like that. Okay, so M shape. And this here is my graph, y equal minus, in bracket, x minus 4 whole squared, in bracket, x minus 2 whole squared. And that there completes part D of the question. Okay, moving on to the final part of this example, so part E. We need to sketch this particular graph. Before we sketch it, we notice that this particular quadratic over here can be factorized. So my first step is to factorize this quadratic. I've got y equal x minus 4 in bracket whole squared, and then I've got double brackets over here. So the factorization of this will be x minus 5, x minus 6. Now, I'm going to identify the coefficient of x to the power 4. We have x squared multiplied by x multiplied by x. This reduces to x to the power 4. So the coefficient of x to the power 4, in other words, the value of a is 1. This is positive. Hence, we have a positive quartic. We have a W shape. And now I'm going to work out the y-intercept. To find the y-intercept, I need to substitute x equals 0. So I'm replacing the x's in the equation with 0. If I do this, I get y equal minus 4 squared multiplied by minus 5 multiplied by minus 6. So if I multiply this, I get y equal 480. So my y-intercept, ladies and gents, is 0, 480. Now I'm going to find the x-intercepts. Substitute y equal to 0. So I'm going to replace y with 0 in my original equation. So my equation reduces to x minus 4 in bracket squared, x minus 5, x minus 6. Each of these in brackets equal to 0. So the roots, or you could say solutions of this equation, are x equal 4, 5, and 6. Right, now onto the juicy part, the fun part, sketching the graph. So here's my coordinate axes. My x-intercepts are 4, 5, and 6, and my y-intercept is 480 roughly over here. It's a sketch, it's not accurate. Now, if I go back to my equation over here, notice that there is a repeated factor, which is x minus 4. So the curve will bounce at x equal 4. But at x equal 5 and 6, it's going to cut. So I'm going to sketch a W shape so that there's a bounce at 4, but cut at 5 and 6. So my graph will look something like this. It's going to bounce at 4, cut at 5, and also cut at 6. So that's what the quartic looks like in this particular case, where there's only one repeated factor. I can label my graph, which is y equal x minus 4 in brackets squared, x squared minus 11x plus 30 in brackets. That there completes the final part of my examples and this particular teaching video. If you found the video useful, please don't forget to subscribe, leave a like, turn on the notification bell so that you receive updates every time I upload a new teaching video.